your chapter 10 goes over systems of equations. So this should be something that's pretty easy for you. You've done it before. So we're going to start with using your substitution method. When you use substitution, you want to solve one of the equations for one of the variables. Then whatever the expression is for that variable, you're going to plug into the other equation. So then you'll be working with just one variable, not two different ones. You'll solve for that variable, then plug that into the equation that you solved for in the very beginning. So if we look at our first example, you're solving the system x plus y is equal to 4 and x minus y is equal to 2 using substitution. So we're going to take the bottom equation, start with that one. So that's x minus y is equal to 2. And I'm going to solve that for x. So I'm going to move that y over and add it to both sides to get that x is equal to y plus 2. Now, because we haven't worked with that top equation, we're going to take that y plus 2 and plug it in for x in that top equation. So that's going to give us x, which we said is y plus 2, plus y is equal to 4. From here, you'll combine like terms. Your y's combine to give you 2y plus 2 is equal to 4. We can move the 2 over by subtracting it to both sides to get 2y is equal to 2. We'll then divide each side by the 2 to get y by itself, and you have that y is equal to 1. Even though you solved for one of the variables, you still do need to solve for the other. So we're going to take that one and plug it in to the y, and x is equal to y plus 2 to solve for the x. You'll have x is equal to 1 plus 2, which means x is equal to 3. If you have that x is equal to 3 and y is equal to 1, your ordered pair, that is your solution, is 3, 1. Your answers for these have to be ordered pairs. They can't just be x is equal to, y is equal to. They have to be an ordered pair. For your next example, you're going to work with 3x squared plus 4x minus y is equal to 7, and 2x minus y is equal to negative 1. If it was me, I'd solve that bottom equation for y. So what we would do is we would take that 2x minus y is equal to negative 1. If we solve it for y, I'm going to move the y over and add it to both sides so that way it's positive. That gives us 2x is equal to y minus 1. And then I just move the 1 over by adding it to both sides. So that's y is equal to 2x plus 1. So we're going to take that 2x plus 1 and plug it in for y in that top equation. So that gives us 3x squared plus 4x minus y, which is 2x plus 1, is equal to 7. You want to distribute that negative into your 2x plus 1 to give yourself 3x squared plus 4x minus 2x minus 1 is equal to 7. We're going to combine like terms on the left side. That'll leave us with 3x squared plus 2x minus 1 is equal to 7. We'll then subtract that 7 over. So that's 3x squared plus 2x minus 8 is equal to 0. You're going to factor this. Your 3 times negative 8 is negative 24. Your factors of negative 24 that add up to be positive 2 are 6 and negative 4. So we're going to rewrite this as 3x squared plus 6x plus 4x, or sorry, minus 4x. Minus 8 is equal to 0. We're going to factor this by grouping. The first we factor out a 3x, second we factor out a negative 4. So that's going to give us 3x minus 4 times x plus 2 is equal to 0. We're going to set both of those equal to 0 and solve. For the 3x minus 4 is equal to 0, we're going to add the 4 over. That gives us 3x is equal to 4. Then we're going to divide each side by the 3. And we have that x is equal to 4/3. For the x plus 2 is equal to 0, we subtract the 2 over. And we get that x is equal to negative 2. So you're going to have two y values here, or two ordered pairs that are solutions. We're going to take both of these x values and we're going to plug them in to the y is equal to 2x plus 1. So if that's going to give us y is equal to 2 times 4/3 plus 1, and y is equal to 2 times negative 2 plus 1. The 2 times 4/3 gives us 8/3. Plus 1, it would be 3/3. So that means that we're going to have a y that's 11/3. For the other equation, your 2 times negative 2 is negative 4, and negative 4 plus 1 leaves us with a y equaling negative 3. So when x is the 4/3, our y is 11/3, so that's one ordered pair. And when x is negative 2, our y is negative 3. That's our second ordered pair. So both of these are solutions. For your next example, we have x squared plus 4x minus y is equal to 7, and 2x minus y is equal to negative 1. So very similar to the one that we just did. We're going to first take the 2x minus y is equal to negative 1, and we're going to solve it for y. So we're going to move the y over, add it to both sides. That gives us 2x is equal to y minus 1. Then we move the 1 over, so that's y is equal to 2x plus 1. We're going to plug that 2x plus 1 in for y in that top equation. So that's going to give us x squared plus 4x minus 2x plus 1 is equal to 7. From here, that negative distributes in to give us x squared plus 4x minus 2x minus 1 is equal to 7. Combine your like terms on the left side. That's x squared plus 2x minus 1 is equal to 7. Move your 7 over, subtract it from both sides. You have x squared plus 2x minus 8 is equal to 0. Your factors of negative 8 that add up to be 2 are 4 and negative 2. So that's x plus 4 times x minus 2 is equal to 0. Your x plus 4 gets that equal to 0. Your x minus 2 gets that equal to 0. You solve both of these. Subtract your 4 over. You have that x is equal to negative 4. Add your 2 over. You get that x is equal to 2. So we have that x is equal to negative 4 and that x is equal to 2. We're going to plug both of those in for that y is equal to 2x plus 1. So it's going to give us x is equal to 2 times negative 4 plus 1. Or sorry, this is y, not x. Y is equal to 2 times negative 4 plus 1. And y is equal to 2 times 2 plus 1. For the y is equal to 2 times negative 4 plus 1, that 2 times negative 4 is negative 8. Negative 8 plus 1 is negative 7. So that would give us the ordered pair of negative 4, negative 7. For the y is equal to 2 times 2 plus 1, that simplifies to give you 4 plus 1, which is 5. So that is the ordered pair 2, 5. For your last example on this page, you have negative x plus y is equal to 4 and x squared plus y is equal to 3. If it was me, I would take that top equation and solve it for y. So we're going to move that y over. Or sorry, we'll move that x over. And we'll just add it to both sides to get y is equal to x plus 4. From here, we're going to take that, plug it in for y in that bottom equation. So it's x squared plus x plus 4 is equal to 3. Since we have an x squared, we're going to move that 3 over, subtract it from both sides. So that's x squared plus x plus 1 is equal to 0. This is not factorable. There are no factors of 1 that add up to be 1. So in this case, you have no solution. For the next part of your lesson, we're going to be looking at using elimination in order to solve. When we're working with these, you need to make sure that one of the variables have the same but opposite sign coefficients. So the numbers in front of the variables have to be the same, but the signs in front of that have to be different. From there, you'll just combine them. It'll cancel out one of the variables, and then you'll solve for the other. Then you'll go ahead and plug in and keep working it. So if we look at our first example, you have 2x minus 4y is equal to -7, and 5x plus y is equal to -1. In order to get your variables to be the same, I would take that bottom equation and multiply it by 4, so that way those y values are the same but opposite signs. So that's going to give us 2x minus 4y is equal to -7 because that top equation doesn't change. That bottom, however, is going to turn into 20x plus 4y is equal to -4. We're going to add these two equations to combine like terms. Your y's cancel. You're left with 22x is equal to -11. From here, we're going to divide each side by that 22 to get x by itself, and that gives you that x is equal to -1/2. Now, I would look at the two equations that are the original ones. If you look at the top equation, it has a coefficient of x that is an even number, so that 1/2 would end up multiplying by that even number, and it'll leave you with a whole number. So we're going to use that top equation now. So we're going to put an arrow to this so we remember that x is -1/2. From here, we're going to have 2 times -1/2 minus 4y is equal to -7. Your 2 times -1/2 gives us -1 minus 4y is equal to -7. We add the 1 over. That gives us -4y is equal to -6. Divide each side by that -4. And that gives us that y is equal to 3/2. So if x is the -1/2 and y is the 3/2, that gives us the ordered pair of -1/2, comma 3/2 for our answer. For an example like your next one where you have 5x plus 3y is equal to 9 and 2x minus 4y is equal to 14, you have two different things that you can do. You can either cancel out your x's or you could cancel out your y's. Your y's already have opposite signs, so I would go with that. To cancel out your y's, you're going to multiply the top equation by 4, bottom equation by 3. So this is going to give you 20x plus 12y is equal to 36, and 6x minus 12y is equal to 42. We're going to combine like terms here. Your y's are going to cancel. You'll be left with 26x is equal to 72. You can divide each side by that 26, and you should get that this is 78, not 72. Sorry, guys. 78. So you'll divide each side by the 26, and you're going to get that x is equal to 3. So now you can pick or choose the top or bottom equation to plug in that 3 in order to solve for y. I'm going to work with the top one, so that's going to give us 5 times 3 plus 3y is equal to 9. Your 5 times 3 is 15, plus 3y is equal to 9. You're going to subtract that 15 over. So that'll be 3y is equal to -6. You then divide each side by the 3, and you have that y is equal to -2. So if your x is 3 and y is -2, that's the ordered pair of 3, -2. That's your solution. For your next question, you have 1/2 plus 3/4 y is equal to 41 over 4, and 3/4 x minus y is equal to 4. I would not work with the fractions. By multiplying everything within each equation by a least common denominator, it will cancel out your fractions. So your top equation, you can multiply everything by 4. Bottom equation, you can multiply everything by 4 as well. So that's going to give you 4 times 1/2, which is 2x, 4 times 3/4, which is 3y, is equal to 4 times 41 over 4, which is 41. And 4 times 3/4 is going to give us 3x. 4 times negative y is going to be negative 4y. And 4 times 4 is 16. We're going to combine not combine. We're going to try to multiply both of these equations by something that'll give us opposites. So that way we can just combine like terms and go from there. I'd rather work with a 6 than a 12, so I'm going to multiply that top equation by 3, bottom equation by negative 2. So that's going to give us 6x plus 9y is equal to 123, and negative 6x plus 8y is equal to negative 32. From here, we're going to combine like terms. Your x's cancel. This is going to leave you with 17y is equal to 91. You're going to divide each side by the 17. So you have that y is equal to 91 over 17. You're then going to take that y and plug it into one of the original equations. I would use the bottom one. So that bottom one's going to give us 3/4 x minus 91 over 17 is equal to 4. You could have also used the 3x minus 4y is equal to 16 if you want to. It's totally up to you. If we rewrite this 4 as something over 17, so that way when we move the 91 over 17 over, it's going to give us 3/4 x minus 91 over 17 is equal to 68 over 17. So from here, we add that 91 over 17 to both sides. And that'll leave you with 3/4 x is equal to 159 over 17. From here, we're going to multiply each side by the reciprocal, so that's the 4/3. The 3 goes into 159, a total of 3 goes into 159 53 times. So it's 53 times 4, which is 212 over 17. So you got your x, you got your y. Put those in as an ordered pair, and you should have 212 over 17, comma 91 over 17. For your next example, you have x minus 2y is equal to 3, and negative 2x plus 4y is equal to 1. We're going to multiply that top equation by 2. So it's going to give us 2x minus 4y is equal to 6, and negative 2x plus 4y is equal to 1. From here, we're going to combine like terms. Your x's cancel, your y's cancel, so you're left with 0 on your left side. That's 6 plus 1 is 7. 0 is not equal to 7, so we have no solution for this one. Your next example gives you 2x minus y is equal to 1 and 4x minus 2y is equal to 2. We're going to multiply that top equation by negative 2. That's going to give us negative 4x plus 2y is equal to negative 2. And 4x minus 2y is equal to 2. If we combine like terms, your x's and your y's both cancel to give you 0. Your negative 2 plus 2 is 0 as well. You are left with 0 is equal to 0. This is a true statement, so you have infinitely many solutions. For the next example, we have 3.1x minus 2.9y is equal to negative 9.5, and 31x minus 12y is equal to 41. We're going to multiply that top equation by 10 to move those decimal points over 1 for each of those numbers. So it's going to be 31x minus 29y is equal to negative 95, and 31x minus 12y is equal to 41. We're going to subtract these, so we're going to change the sign on each of those terms on the bottom equation. So that's going to give us those x's canceling out. That negative 29 plus 12 is negative 17y, and negative 95 minus 41 is negative 136. So we're going to divide each side by that negative 17 to get y by itself, and we are left with y equaling 8. So from here, we're going to take that 8, we're going to plug it into one of the original equations. I'm going to use the bottom one, so it's going to be 31x minus 12 times 8 is equal to 41. The 12 times, or the negative 12 times 8 is negative 96, so 31x minus 96 is equal to 41. We're going to add that 96 over. That gives us 31x is equal to 137. So from here, just divide each side by that 31 to get x by itself. And we have that x is 137 over 31. So we have our x and our y. That gives us our ordered pair of 137 over 31, comma 8. Now we're going to look at some word problems. For this one, we have a total of $12,000 that's invested into two funds paying 9% and 11% simple interest. The yearly interest is $1,180. How much is invested at each rate? So we have one equation that we can work with of one of the accounts being X, the other being Y, and that equaling the 12,000. And then the other equation that we're going to have is that 9%, which is 0.09x, plus the 11%, which is going to be 0.11y, is equal to the 1,180. We're going to start by multiplying everything on that bottom equation by 100, because we're moving that decimal point 2 places to the left, or sorry, 2 places to the right. So we're going to have x plus y is equal to 1,200, or 12,000. Then we have 9x plus 11y is equal to 118000. So from here, we are going to multiply that top equation by negative 9. So that way our x's cancel. That's going to give us negative 9x minus 9y is equal to negative 108,000. And 9x plus 11y is equal to 118,000. We're going to combine like terms here. Our x's are going to cancel. That negative 9y plus 11y is 2y. And negative 108,000 plus 118,000 is 10,000. So we just divide over that 2, and we get that y is equal to 5,000. So we're going to take that 5,000, plug it into that top equation. So it's going to give us x plus 5,000 is equal to 12,000. We're going to move that 5,000 over, subtracting it from both sides. So that gives us that x is equal to 7,000. So because this is a word problem, you got to look at what you're working with. You're working with money, you're working with accounts. So in account 1, you're going to have $7,000. And in account 2, you're going to have the $5,000. In your next example, it tells us that 2 cheeseburgers, we're going to use those as X, and 1 small order of fries, that's going to be Y, from a fast food restaurant contain a total of 970 calories. 3 cheeseburgers, we said that's X, and 2 small orders of fries, that's Y, contain a total of 1,640 calories. Find the caloric content of each item. So first one we have is, or first equation we have is 2x plus y is equal to 970. The second is the 3x plus 2y is equal to 1640. I'm going to multiply that top equation by -2 so that my y values cancel. So that's going to give us -4x minus 2y is equal to -1,940. And we still have the 3x plus 2y is equal to 1640. We're going to combine like terms. Our y's cancel. We're going to be left with -x is equal to -300. We change the sign on both sides, and we have that x is 300. So that cheeseburger is 300 calories. From here, we're going to find out how much the fries are. So that means we're going to plug that into the top equations. It'll be the easiest to work with. So it's 2 times 300 plus y is equal to 970. That 2 times 300 is 600 plus y is equal to 970. We move that 600 over, subtracting it from both sides, and we get that y is 370. So that means the fries are 370 calories.